cannot be recycled, regained. They go in what we call a waste bin. So it's all sorted at the source. When they come and collect, they collect them as sorted. So this is a big challenge, growing challenge as the world population grows and as we move more towards urban settings, increasing amounts of domestic and commercial waste becomes a big challenge for us to manage. And of course, if we do not have proper facilities to collect and sometimes store, sometimes dispose of, that may result in pollution of the lands, the water, air, and of course deplete resources, and of course contribute to climate change. You'll say, well, how so? If you leave big pile like mountains of garbage, they'll call it, or waste unattended. And if you have biodegradable waste in there, and methane gas will start forming, and then that gas will ooze out into the environment, which is one of the, of course, greenhouse gases. So, there are tightened regulations to control that. Governments enforce strict restrictions in many countries on waste disposal systems to mitigate environmental impacts. So it becomes in every municipality a very important aspect how they could manage waste. Manage is, again, reduce the size and recycle and regain. All three. Effective technologies such as fluidized bed systems are essential for sustainable and environmentally friendly waste management. Okay, so it's not just to get rid of it, it will have to be done in an environmentally sound manner. And the fluidized bed technology offers a very good options in fulfilling that requirement. Okay, we see this growing in many countries. I have designed a couple of them for different applications in the waste management area, but especially in Asian countries and Thailand and many others, they are widely used. It plays a key role in solid waste management, and again, as I said, through incineration, it is possible to reduce the amount of waste material. And we cover this when we burn things. We spew things out into the atmosphere. There could be a lot of hazardous components, as well as, of course, large amounts of CO2. So this has to be taken into consideration as well. There are other options available, but in the interest of time, whatever, we're just going to focus on the thermal aspects through which in using fluidized bed technology. We touched on this many times, that the processes that we can embark on fluidized beds is through combustion, gasification, and and of course drying. We covered last night, and opposite of it, of course, could be cooling if it's needed. So, what are the advantages of using a fluidized bed? Fuel flexibility is very important. This slide, it's not just specific to waste, but it covers a number of things that we already touched on. Solid waste is one of them. Environmental compliance, again, we talked about some very strong and practical aspects of fluidized beds in terms of emission controls, mostly in the form of sulfur oxides or nitrogen oxides, given again its operating conditions and also its ability for in-situ sulfur removal. And then something else comes out when you burn something. Combustion is an exothermic reaction. It releases heat, and therefore there's an energy conversion process that takes place. Once you're able to bring it to the ignition temperature and hope that the reaction will be self-sustaining, and then it will continue burning and release heat throughout. So, what are the applications? Again, we've talked about this, but as I said, you can integrate this into a power plant design if possible. If it's really, really large and you build an infrastructure that counts on sustainable amount of waste as fuel, you may consider power generation, but mostly it is in the form of heat that is released. Okay, I don't know if you heard me what I said last, but I'll repeat it. If you have a large enough facility that counts on a sustainable flow of waste material as fuel, and then you can build it as a power plant. Okay, sorry, but that it was an. Never mind. Okay, let's go through this. So, yeah. So we can use the circulating fluidized beds successfully in incinerating waste, and at the same time do it, of course, in an environmentally sound manner, but also capture a lot of the heat from it. And as I said, if it's large amounts, then we can produce steam, turn steam turbines and produce electricity, and also we can use it as for district heating if heat is necessary. So this is an externally circulating fluidized bed. Here is the bed. Here you have wastewater treatment plant, sludge from wastewater treatment plant coming. It's industrial waste is being fed, but you have to use auxiliary fuel to bring this bed temperature to the initial ignition temperature of the waste material sludge. So gradually you co-fire until the combustion is steady, then you shut off the auxiliary fuel if it sustains itself. Otherwise, you'll have to continue it in small amounts. So as bed material, you put sand in. As a sulfur dioxide scrubber, you put limestone in, and it produces a lot of heat. You take this heat, and in the boiler section, you boil steam. Of course, these are two closed systems. Water loop is completely separate. You take the water out, but then you have ash particles you have to collect, and you have the gas to deal with. Now you need to separate. For the gas to be sent to the bag filters, you will need to cool it, otherwise you'll destroy the bag filters. Then you go through some scrubbers and catalytic reactor for nitrous oxides, and if there are any. In this case, there are, because you temperature and from all the waste material, you have to ensure that it's clean before it is discharged through the stack. Okay, so this is externally controlled. Uses scrubbers and all the other things in order to the what could we use here? We can use the solid residues from here, collected and treated to avoid environmental harm. The Usually ash, if it's coming from a power plant, coal usually, but other cases, you wonder what you do with ash. What do you do with the ash? Just think about it for a second. So you can use ash. It's one of the main filler material for example, road construction. Okay, it can be used as a construction material, not as a sole, but as filler or auxiliary material. So there are lots of use of it in construction industry. Liquid residues, okay, they have to be discharged properly, or they have to go through a second incineration process. Integrating the process with, again, capture the heat, and environmentally, now you have reduced the size of the waste significantly. You released as clean gas as possible, and within acceptable limits and standards. And at the same time, you produced useful heat either for power generation or district heating or process heating. Internally circulating fluidized bed, as the name implies, instead of doing it externally, you circulate this within the bed. This is a unique design. You will recall from your fluid mechanics, there is sudden contraction, and then sudden expansion. When the dense bed is here, gases are released with some particles, they enter into a large area, and then there, around wall, there's recirculation patterns, and then they are thrown out, and then they come back. So it is a very effective internal circulation system. It is, again, if you do not, this is for smaller loads, but it is extremely effective and a simpler design than the circulating one, of course. Basically, operating temperature, as we all said, this will be around 900 degrees. And around that temperature, you minimize NOx formation. Then, as you see here, you don't have very expensive scrubbers and catalytic converters. So, what are the other kinds of incinerators or waste to energy technologies? Rotary kilns and grate furnaces, they are two most popular ones. And they usually, the operating ranges are different. I will show you. But given the rotary kiln, let me go here, show you first what it's like. This is the kiln. It is usually its length to diameter ratio is about at least 8 times length to diameter. As you can see, it is placed inclined to facilitate better movement, and of course it rotates. Okay, slow rotation. With all these, enable use primary and secondary combustion chambers within it. You can reach high temperature. Therefore, it is very, very useful for the treatment of hazardous waste. Okay. Two very important parameters in destroying hazardous waste. Think about it, what it will be. Temperature it has to be at high temperature, and at high temperature, how long you keep it there. So residence time and high temperature, there are two essential things that will make sure that these hazardous waste is destroyed. You can adjust the within, of course, given operating conditions, residence time, given the by adjusting the rotational speed. Again, as I said, toxic material substances, especially could be considered very hazardous, like petroleum coke, anything with polyaromatic hydrocarbons in it, and those are they have to be destroyed before anything is released. Again, it can be in diverse. It can handle diverse range of materials. Doesn't mean that you have to just burn or incinerate toxic substances. You can do it together with some other materials. But anyway, this is what it is. The great furnaces, very simple. Great. Um, uh, Moving back and forth, collecting the ashes underneath. It is it's a simple design. It is used for non-hazardous municipal waste and primarily used to reduce waste volume, decreasing the quantity approximately one-third. Then we have the fluidized bed combustors. Again, it's a more modern technology than those two, mostly predominantly for non-hazardous waste, but includes sludge and other treated materials. Okay, very effective for energy recovery, and you can use it again to scrub the gases effectively. So this is the rotary kiln, as I showed you, and this is the reciprocating grate incinerator. As you see, this is where the material is fed. Here is the combustion zone, given the inclined design, and this is reciprocating again. The movement it enables by gravity the ash to be collected at the bottom, and then air is moved. You put secondary air to burn any unburned fuel there, ensure good combustion, and at the end, if needed, you can also provide a tertiary air. This is a very simple but very, very effective design. Again, mid-sized municipalities, they prefer this one because of its ease of its construction and operation. So if you need to make a choice which one to use and justify fluidized bed, selection of fluidized bed, you can see that its full capacity is much higher than the others. And it's the others use much higher excess oxygen or air, and but you have to make sure that the fuel, in this case waste, is properly processed. That means you have to sift all the non-combustible material out, and it has to be again sized in a way that, remember what I said yesterday, group D is the largest size we can go in. Group D will be around 10 millimeters. You have to ensure that you don't have larger size particles. For example, if somebody throws pair of shoes in garbage, and then you can just throw those shoes in the fluidized bed, it goes through a chopper and sized appropriately before it can be gotten rid of. Um, Again, these are some of the things that you need to take into consideration. What kind of fuel you can feed into it. I'm sorry, I'm just passing a little fast. Um, but I think I'm making sense. So here's an example. This is an existing facility in Austria, Vienna. It's composed of 4 fluidized beds and 2 rotary kilns. Okay, so it covers a wide range. Rotary kilns make sure that all the hazardous waste go through that, and the fluidized beds, they look after the others. Look at the numbers. 180,000 tons of municipal sewage sludge annually, 90 tons of non-hazardous waste, and 90,000, I'm sorry, tons of hazardous waste annually. These are significant amounts. For energy recovery, it generates 56,000 megawatt uh, hour of electricity and 440,000 megawatt hours of district heating. So it is a combined CHP, combined heat and power plant. Its fuel is waste material, and it produces electricity and feeds it into the grid, and also a lot of heat for district heating. Okay, both for comfort heating and also hot water. 1,800 tons of metals recovered through reduction and extraction. Residue management produces 62,000 tons of solid residues. Out of all of these, a lot of solid residue, which are treated and disposed of in compliance with environmental regulations. And as I said, to do all of these, they have 4. These are internally circulated fluidized beds and 2 rotary kilns, okay, to accomplish this. You're familiar with this, but it is, again, to remind you that when you, instead of burning, you have an option of gasifying the waste material. The same principles that we discussed for coal or biomass, that you provide enough oxygen to burn some of the fuel, but sub-stoichiometric amounts to either starve to oxygen through pyrolysis, and also under stoichiometric amount for gasification. And out of gasification, you produce syngas, and then you do all kinds of things with that produced syngas. So remember, I talked about incineration, but also gasification is also a possibility. And in some cases, there is more leaning towards this one simply because of carbon dioxide capture or reduction. I'm repeating what I covered in the gasification lecture, but these are the materials that you can use as waste material. You're familiar with this, but I thought I will show it to you again, the types of gasifiers, including fluidized beds. And you're familiar with this one as well. I showed you the operating ranges of fluidized bed gasifiers. For combined heat and power from waste, basically, the dual system is used. You have the combustor incinerator. You basically accomplish this externally, and you utilize the flue gas. You deal with it, but what you do, you circulate hot solids. Hot solids are the heat source for the gasifier to handle waste material in the form of biomass, and you just keep going. Or you can do this indirectly, directly or indirectly. You can do this. For methanol production from waste, you can here you do the fluidized bed system here, gasifier, and then the idea is the methanol synthesis takes place here, then the purification, and you use it as fuel in internal combustion engines or in turbines. This is another way of, again, methanol production. I'm just giving these as some examples that in modern day that you can use. Methanol is an incredibly important, of course, production because it's an energy carrier. You instead of like tons of waste or biomass coal, you've put it in the form of methanol, which is a lot. It contains a lot of energy, but also transportation is a lot easier. Uh, I sincerely apologize. I flew through this, but I can't continue anymore. I have to stop here. Okay. I hope this was useful. Again, this final lecture was just um, 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 a form of application, and we applied it to waste management. I may have taken shorter time, but I think the idea was to impart all the necessary information for you to have a good understanding of it, beyond which I think you will need to, of course, do your own studies and research to get more in-depth understanding of all of these, and together with some very detailed calculations. They are all available. I wish if we were doing this in the form of a 3 month long course, I think we will have covered all of those in detail, but nevertheless, I'm going to show you one resource. Oh, it is heavy. If you can see this book, it is called Steam and Generation and Use. Okay. This is an incredibly useful. This is done by a boiler manufacturer called Babcock and Wilcox. See if it is available to your library. Again, if I were there, I would have brought. It's quite heavy. But this is the absolutely the most detailed, fundamental book for a lot of the topics we covered. But it covers a much wider range of systems and very detailed fluidized bed systems. With that, I apologize. I cut it short, but I think I have accomplished my objectives that were given within the list of contents of this course. And I wish you all the best, and thank you for your attention. Yeah, Professor Tahu, one thing that we couldn't do is I'm still committed to have a half an hour meeting, whatever, with those faculty members who would like to do it. But give me a few days to recover, okay? And then we'll do it later. Okay. All the best. Bye-bye.